just wanted to do a quick introduction to some nice, easily accessible satellite imagery tools. So it's mainly going to be a signposting exercise to let you know that these things exist, rather than going through them in a lot of detail. However, if any of them look particularly interesting, then we can have a chat about that at the end, and make them the topic of a future webinar and spend more time delving into that specific tool. There are so many remote sensing imagery tools available, and they range from really user-friendly all the way to extremely complicated. But for this webinar, we're just going to focus on some really straightforward tools that allow you to get going with accessing some of that satellite imagery, so you can use that to inform the work that you do in your catchment as quickly as possible. So the availability of satellite data, it's increasing all the time. There are really rapid advances in spatial resolution. There are freely available resources, paid for resources, and usually those commercial options offer the highest resolution imagery. But in this webinar, we'll be focusing on the freely available imagery. And one of the most useful imagery resources that we have access to is the Sentinel-2 mission data. So it's a European satellite mission. It's got 2 satellites that orbit the Earth, and between them, they revisit every location roughly every 5 days. You might not get a cloud-free image on that day, which is another matter, but it's coming around every 5 days-ish. So the satellites sample 13 spectral bands, and that allows the data to be used for a really wide variety of remote sensing applications. And they have different spatial resolutions for each of those bands. So, for example, the red, green, blue, and near infrared bands, they have the highest resolution at about 10 meters. And the best thing about Sentinel-2 data is that it's made fully available without charge, which is a really brilliant resource for us. Before I go into some of the tools available, I'd like to just quickly give a brief overview of some of the remote sensing indices, which are especially useful for some of the work that we do in the Rivers Trust movement. And I'll refer to these at various points in the webinar. So all of these indices are calculated based on the differences between values of light reflected at different wavelengths. So by using the multispectral data, we're able to visualize some really useful information to inform our work. So the first one is NDVI. So that's the normalized difference vegetation index. And it's a really useful tool. It can be used to measure the health of vegetation based on how plants reflect light at different wavelengths. The next one is the normalized difference moisture index, or NDMI. And you can use that to look at the water content of vegetation, which makes it a really useful tool for monitoring droughts. And finally, there is NDWI, which is the water index, and that's really helpful for looking at highlighting water bodies in the landscape. So I'll come back to those later in the session. So we'll go and have a quick look at some tools. So one of the easiest places to start is just by using Imagery. So you can browse through the Living Atlas and access a wide range of imagery products. You can add filters to search for imagery layers, and you can also limit your search to those layers that are just marked as authoritative by Esri, so the ones that you can have confidence in. For example, here we can open up the multispectral Landsat imagery in an ABOL map, and you can explore it. It opens up for the whole world, but you can zoom in to a particular area that you're interested in, as you can see here. It'll take a second. It's quite low resolution imagery compared to some other data sets, but it's over a long period of time, which can be useful. There's also a range of apps that Esri have created to help you explore the imagery. So Esri's Landsat Explorer that allows you to apply a range of remote sensing indices, and you can also filter them, and it's really user-friendly. So Landsat is the longest running program of remote sensing data. So the first sensors were launched in the 70s compared to Sentinel-2, which was launched in about 2015 and 2017. So though the spatial resolution is much lower than Sentinel-2 data, if you're interested in long-term trends in your catchment, but you don't need much spatial detail, then Landsat might be a useful resource for you. Esri have also created a Sentinel-2 Explorer, which in theory allows you to compare dates and add masks based on various remote sensing indices. However, I continually have a sign-in issue with this app, which means I can't get it to function as expected. But for Sentinel-2, I actually prefer to use Pro to explore it anyway, and another app that I'll show you in a few minutes. But it may be that this app works for you, so have a look and see. Esri, they also produce a number of configurable apps that allow you to so curate your own imagery data and allow your stakeholders to explore it. So there's something called the Image Mask app, and I think that's particularly useful because you can set it up to allow people to explore how things have changed between dates. And you can also use a masking feature to highlight those areas of change. And you've got the main benefit that these Esri configurable apps, you can embed them really easily in things like story maps. So it can be brought into a much bigger project that you'd like to get across. Next up, I'd like to have a look at how you can take those imagery layers on the Living Atlas into Pro. And that means that you can view them alongside your other data and also carry out analysis on them rather than just looking at them. For example, you can search for Sentinel-2 in the portal in the Living Atlas. So here you can see all of the imagery layers available from Imagery, and they've been pre-configured to highlight particular features such as agriculture or geology. But I've just added the main Sentinel-2 view imagery layer to the map. And the most recent cloud-free image is displayed by default. You can also open up different views, for example, if you need to find something from a particular time of year. So you can filter the views. You need to open up the Explore Raster Items tool from the Data tab next to the image service layer setting. And in this tool, you should be able to choose the area of interest you'd like to filter the views for. You can also specify an attribute based on the data fields. So in this example, we want to find images with low cloud cover of less than 5%. And you can then click on the Apply button, and there's a list of images. The thing to note is that the Sentinel-2 images are available on Esri. They're only available from the last 14 months. So that's just something to bear in mind if you're looking at longer trends than that. There should also be an option to filter by image acquisition date. However, it's not working at the moment. I've been in touch with Esri about it, and they've confirmed it's a bug, and they're looking into it, so that should hopefully be available in future. Once you've added your image to the map, you can also use the Data tab to apply a range of different indices, such as NDVI or the moisture index. So we've got that up here. And you can add views from different times of year, and then, for example, use the swipe tool to compare between the images. So it's really quick and easy to add that data into Pro. In order to work with just your specific area of interest rather than the whole scene, then you can use raster functions to clip the data. So for those of you who haven't used raster functions, they apply processing directly to the pixels of imagery, as opposed to geoprocessing tools, which actually write a new raster to a disk. And the raster functions' main benefit is that they work really fast compared to geoprocessing tools, because the output isn't actually being saved to your computer, it's just being displayed on the fly. So Pro has a huge range of preset raster functions, but you can also create workflows by stringing these raster functions together, or creating custom raster functions for a specific task. We can look at this in more detail in future webinars, because it's a whole topic on its own. But for now, we're just going to use the clip raster function to clip the imagery layer down to our area of interest. And remember, because the data isn't actually being saved to the disk, at the end of your analysis, if you want to save the final output, then you do need to export it using a traditional geoprocessing tool, or you risk losing it by accident. Excuse me. So if you go ahead and open the raster functions pane and search for clip, then we can select the Sentinel-2 view as the input and add the area of interest to the clipping and geometry input. And if you tick the use input features for clipping geometry box and leave the remaining defaults, and you can see that really quickly we've clipped our NDVI layer to the area of interest. And again, just to reiterate that it's not been saved to the disk, so it's not taking up unnecessary space on your system. Next, you can use the greater than raster function to create a layer which identifies which pixels are below or above a certain value. So for example, if we want to select all the pixels which have high NDVI values, for example, above 160 in this case, then we can open up the greater than raster function. If we then add our clipped imagery layer of NDVI as the input to raster 1 and our value of 160 as a constant for raster 2, that will then return a layer which gives a value of 0 if the pixel value in our input raster is below 160, and a value of 1 if the pixel value in our input raster is above 160. There seems to be a little bit of a bug where the the symbology makes it appear as if all the return cells are 0, but if you change the symbology, then it appears to write itself. So now we have this sort of either or raster, then we can add that as an input to the next step, which is using the con tool, which is the conditional tool, again as a raster function. So if we use the raster that we just generated as our input, we need to specify which values we'd like to apply. So if the value in our input raster is 1, then we'd like to return the value of our original NDVI. However, if it's 0, then we want to return a value of 0. So that means that we'll end up with a raster showing us the values of NDVI where it's above our specified limit of 160. Otherwise, it's set to 0. And that's what you can see now. And we can change the symbology to make those lower values transparent and also pick out particularly high values of NDVI. So finally, you can also save this raster to disk just by exporting the raster to a geodata. And as I said earlier, you can actually save that chain of raster functions for future use on another data set. So if this is something that you think you'll be doing over and over, then you can just save it and apply it to other views in future. So you can see here, our output has got the high values where we've got high NDVI, and then it's just transparent where it was low. The next tool I'd like to show you is the Sentinel Hub EO browser. So this is it's an online tool and that allows you to easily find Sentinel-2 images and apply a range of indices to the data. It's free to explore the data, and I think it's really user-friendly. It's also got a really nice time-lapse creation feature, and that's really useful for easily visualizing changes over time without getting into analysis in GIS software. So first look at how you can quickly search for and then apply different remote sensing indices in the browser. So the first thing that you need to do is to select which data sources you want to view data for. So in this example, we're going to look at Sentinel-2. And on EO browser, you can look at all the historical data for Sentinel-2, rather than just being limited to the last 14 months as you are in Esri. So it's much more comprehensive. So if you enable the advanced search option, you can filter the results to a maximum amount of cloud cover and also specify the dates that you're interested in. So for this example, we're going to filter the images by maximum of 5% cloud cover. And we just want to look at images between May and September of this year, last year actually. And then when you press search, you'll get a results pane with a preview of those images matching your search criteria. So you scroll through those until you find one that you want and click visualize. And then the data just appears in the main pane. You can then choose to apply one of the remote sensing indices for the image. So here we can easily look at NDVI for a particular area to assess vegetation health. Or you could look at moisture index for the same area. Also, if you click on the drop down next to each index, you'll find the symbology key and an explanation of that index. There are lots of indices available here, so I'd recommend just having a play around and see if they can tell you anything interesting about your catchment. Next up, quickly show you how you can create a time-lapse video using the EO browser. So this functionality requires you to be logged in, but it's free and easy to sign up. So firstly, you pan the map to the area that you're interested in and then draw a polygon, or you can also upload a boundary file. And when you've done that, if you click on the film icon on the right, then it opens up the time-lapse configuration pane. So you can specify the date range that you're interested in, and also choose to select an image per orbit, day or month or year. And again, you can specify cloud cover and tile coverage. So once you've done that, the images matching your query will be returned. And you can select the images that you want to include in your time-lapse video. So for example, here, there's one of the images is a bit blurry. So you can just untick that and it won't be included in the selection. You can preview the time lapse and you can also download it. So it downloads as a GIF, I think is a default, but you can also download it as an MP4. And finally, there's a share button to make it really easy to share it via social media. So it's just a really quick, accessible way of looking at time-lapse imagery using indices. You can also apply custom scripts to the Sentinel-2 images. So for example, if you select custom at the bottom of the indices option, then you can create a custom visualization, or you can apply one of a huge range of custom scripts that you can access on the Sentinel-2 repository page. So I've added a link to this page at the end of the presentation. That you can have a browse around and see if there's something relevant to your catchment. Here I'm going to show you the barren soils script. So you open the page, copy the code, and then if you go back to the EO browser, we can paste this code into the pane and it will apply the script to the imagery. And then you can see the areas of barren soil are highlighted in red. And finally, just to show you how to download these images, So you can bring them into desktop GIS and analyze them alongside your other catchment data. So you can click on the download image icon on the right-hand side. You can then download a basic image as a JPEG, or you can choose to download the analytical layer. And that's the one that you want to if you're interested in doing any analysis in GIS. You can download a preset visualization, for example, NDVI or moisture index, or you can select individual bands, or you can download your custom visualization, which is what we'll do here. You can change the download image format from the default, which is a non-georeferenced JPEG, to a TIFF. And then you can change the image resolution and coordinates if necessary. And then just click download, and you can add that directly into ArcPro, so you can see it alongside your other data. I've put together a list of useful resources that I found or mentioned in the webinar. So I've got the links to the various apps that I've covered, some useful workflows, and then also a link to that custom scripts page for the EO browser. So that's pretty much everything I was planning on covering on the imagery tools. I know it's been a really quick sort of run through of what's available, but like I said at the beginning, if there's any of those look particularly useful, then we can cover them in future webinars. But does anybody have any questions at this point?